Okay, ladies and gentlemen, today we're going to learn about how we can solve one-step equations by using what's called inverse operations. Okay, I'll discuss that a little bit in a minute. What you need is your note sheet for this lesson that's eventually going to get cut on the dotted line and taped into your notebook. We're going to start on this side of the note sheet where it has some definitions. So remember, an equation just means two things are equal. A solution is an answer that when you substitute it makes it true. And in order to solve an equation, it means we're going to find the answer to that equation. So some hints that we're going to use in a minute. We're going to draw what's called a locker, which actually looks like your locker that you would keep your book bag and your coat in out in the hall. And then of course we're going to show and check our work. Now here's where we're going to be really focusing our attention today on how about we're going to do this. Things to remember when solving an equation. What you need to remember first is always get the variable by itself. So you can see how I use the variable x in both of these examples, and then I use the variable y, and I went back to using x in our last example. So those are the variables in each equation, and again, we're going to be working to always get that variable by itself. And again, we're going to use inverse operations. Inverse just means opposite. So you already know a lot of your opposite operations that we've been working on, and we're going to use them to solve. The third thing is to remember, what you do to one side of an equation, you must do to the other side. Think about this as being a little teeter-totter. All right, there might be one at the park where you go visit or the playground, and sometimes if you have one or two kids on one side, but only one kid on the other side, it becomes unbalanced. So you want to try to keep the weight equal on both sides in order for this equation to be balanced. It's again a lot like a teeter-totter. So again, we're going to be doing things to both sides of the equation to keep it balanced. Now this section here reminds us what inverses or opposites are for each operation. The opposite of addition is subtraction. And the opposite of subtraction is addition. They undo each other when we add a number and then subtract it, or if we start out subtracting, if we add it back, they undo each other. Multiplication's opposite is division, and division's opposite is multiplication. You'll learn more about inverse operations when you do more learning with algebra in 8th grade and in high school. Now a couple other quick things to remember. When you have a number next to a variable, it means that you're multiplying. So say we have the expression 3x. This really means 3 times the value of x. And then down here, if we have a fraction, it means there's division in there. So this says x divided by 3, but sometimes we look at it as x over 3. It really means x divided by 3. So you really have to identify what operation you have, and then you're going to be using the inverse to undo that operation and eventually get the variable by itself. So one thing I do want to point out is that sometimes you have an equation that you can guess the answer to. Some of you are very, very good at your calculating, so you might be able to guess the answer to this equation right away, and that's fine. Okay, the problem with guessing your answer is it sometimes takes a lot of time, and when we get to equations that are much more complicated than this, I don't want you wasting 20 minutes just to guess the right answer when there's a nice method that allows us to do it. So here's our method. Okay, the one hint I talked to you about earlier is to draw your locker. Well, here's where the locker comes into play. When you have an equation and you see who's sitting on this side and you see who's sitting on this side, that equal sign is like that middle part of a teeter-totter. Remember we talked about it being balanced? Well, that's where your equal sign is. So by drawing this big rectangle, it almost looks like a locker because the vents in the top of your locker look like that. It helps you keep the two sides of that teeter-totter or that equation equal. On this side, you know you have a 10.98, so there's not much going on over here. On this side, you do have more going on because you've got the variable x plus you've got the 1.47. So here's what we're going to do, guys. We already found the variable. It's right there. But it's kind of crowded because you also have that 1.47 sitting with the variable. So here's where we use step 2. We're going to use inverse operations. The opposite of adding 1.47 is subtracting 1.47. If this was a person sitting next to the variable on the teeter-totter, it would be like us kicking that person off. So if that person got kicked off, we no longer have it sitting with x. All we have on this side is x. So I'd like you to bring your equal sign down inside the locker, because on this side of the equation you're going to do some math. Now you have a choice. You can do these by hand, or you can get your calculator and you can put in 10.98 minus your 1.47 like I'm going to. I don't want to make any mistakes with my borrowing or anything. So it looks like we have the answer of 9.51. Okay, and that sounds like it's a good answer, but let's verify by doing our check. So x plus 1.47 is supposed to equal 10.98. I think x is 9.51, so we're going to plug it in. And then on this side, we already know it's supposed to equal 10.98, so we're going to take our calculator and we're going to check our work on this side. Do we really have 9.51 plus 1.47? Yep, it's 10.98. So that means we have successfully found our solution, and we did opposite operations to get there. So let's look at the next equation. We have our variable x minus 8 3/4 equals 20 1/4. So if you're getting nervous by having the fractions here, don't be, because we've got the use of our calculator if we need it. So remember, the hint I gave you was to draw your locker to keep the two sides balanced. Find your variable. Okay, your variable is x, and it's sitting next to this 8 3/4 that we want gone. We really want x to be by itself. So we have to do the opposite. Instead of minusing 8 3/4, we are going to add 8 3/4. Now remember, we're doing things to both sides of the equation to keep it balanced. If we only added or subtracted on this side, the teeter-totter would be way unbalanced. So we need to keep it balanced. We got rid of the 8 3/4, which means we got x by itself. On this side, do you know what happens when you add 3/4 plus one more quarter? It's one whole. So if I take my 28 that I get from adding my whole numbers plus one more, it gives me 29. So checking your answer, we have to make sure 29 minus 8 3/4 really does equal 20 1/4. So I'm going to plug it in, and then I can show you something on the calculator. If you have to do 29 minus 8 3/4, did you know that 8 3/4 is the same as 8.75? And I get the answer 20.25. Well, guess what? 20.25 is actually the same as 20 1/4. So I can show that that checks. This is the correct solution to my equation. So we've practiced an equation that needed us to subtract, that needed us to add. So we're going to move on, and we're going to look and see what we have now on this question. All right, so on this question we have 7.23, and it's stuck to the variable y. Remember what that means. When your number and your letter are tight together, it means there's multiplication going on. So guys, we said the inverse operation, the opposite of multiplying, is divide. So that means we have to show that we're dividing this side by 7.23 and we're dividing this side by 7.23. 7.23 divided by itself is just 1. When we're doing these, we don't bother putting the 1y, we just put down y. Now, on this side, we have to show 36.873 got divided by 7.23. So again, this would be a very difficult question to guess the answer to, and that's why we're having you use calculators and we're having you use this process. So now to check, 7.23 times 5.1. Let's check it. 7.23. We got a glare on the screen. 7.23 times 5.1. 36.873. We are doing well. 36.873. Show that it balances out. And you can put a little check mark there. Okay, so for our final example, we have to draw our locker. We have to find our variable. Our variable x is being divided by 5.6. So remember, to get rid of division, we're going to use its opposite. We're going to multiply by 5.6. Now, some students on this side feel very uncomfortable understanding what's going on. So you can put a 1 under the 5.6 And you can remember that these are going to cancel out. So that's how we do get our x by itself. And on this side, 10.8 times 5.6, 60.48. And we're going to check to make sure what we found is really the solution. So we copy our equation, we plug in our answer. We want to verify that it really does give us 10.8. So we need to put in 60.48 divided by 5.6, and we do get 10.8. So what you're going to do now is you're going to verify that you have all your notes filled in. You're going to take your scissors and you're going to cut on this dotted line. And then you're going to tape it in your notebook. And I believe we're working on page 45 and 46. So it needs to look like something like this when you get done with your taping. And then see me for your practice sheet so you can get some more practice solving one-step equations.